that asks, which country is the leading economic power in the world? Of those sampled, 448 said China. At the 5% level of significance, do the data provide sufficient evidence to conclude that at the time more than 40% of US adults considered China the leading economic power of the world? Okay, so let's formulate our null and alternate hypothesis. And so we're tested to claim that more than 40% of US adults consider China the leading economic power in the world. And so we know that the null hypothesis always contains the equal signs. So this is about a proportion. And so P is equal to 0.4 or 0.40 if you want. The alternate hypothesis is basically the claim here. We want to test whether this P is greater than 0.4. All right, determine the significance level of alpha. This is 0.05, which is the probability of making of a type 1 error. And so when you set this in practice, you want to probably think about the ramifications or consequences of making a type 1 error and type 2 error. So these errors always involve the null hypothesis. So let's discuss what the null hypothesis is in terms of the context of the problem. So 40% of US adults consider China as the leading economic power, right? Okay, so what is a type 1 error? Well, a type 1 error would be rejecting that 40% of US adults consider China as the leading economic power when in fact it's true. So what's a consequence of this? Well, there's many possible consequences or ramifications of this. It depends how you use this particular information. And so here's one example, probably many. And so maybe politicians might run for office on the claim that China is a leading economic power and use this as propaganda to get elected, since more than 40% of adults have this opinion, for instance. All right, what's a type 2 error? Well, failing to reject that 40% of US adults consider China as the leading economic power when in fact it's more than 40%. In other words, the null hypothesis is false, and we're in fact more than 40%. And so what's the ramification of that? And there's many you can probably think about, but here's an example. The underestimation of the public perception could lead to a lack of informed public discussion about the challenging global economic landscape and its implication for the US. All right, well, next thing to do would be to compute the test statistic. And in order to do that, we need to find p hat. And we know we have a sample of 1,015 US adults. And the number of people who agreed with that statement, that China is the leading economic power in the world, 440 agreed with that statement. And so p hat then is just 448 divided by 1,015. And so we have 448 divided by 1,015, so minus p, which is the value given in the statement, the null hypothesis, so 0.40, divided by the square root of 0.40 times q, which is just 1 minus p, so that's 0.60, and then divided by n, which is 1,015. All right, so computing this, I believe we get something like around 2.69. Okay. All right, and so now we pre-computed that, but let's go ahead and now calculate the p-value. We're using the standard normal distribution because we're talking about a proportion here, and it's a z-score or a z-test statistic or z-test. And we also know that from the alternate hypothesis, we know we're conducting a right-tailed test. Okay, and so here is the standard normal distribution. 2.69 is probably over here somewhere, and here we have, it's a right-tailed test, so the p-value is to its right, and that's the p-value right there. Okay, so to do this, you have to use some kind of technology. When I did this calculation already, I used Excel, so in a empty cell, I typed equals. And since it's a right tail, the area is to the right, I went 1 minus norm dot dis, and then typed in 2.69 for the test statistic. You probably might want to include more decimal places to get a better estimate, and then 0 for the mean of the standard normal distribution, 1 for the mean of the standard normal for the standard deviation for the standard normal distribution, and then 1 for true. And this roughly gave me 0.0036. Okay, so this told me the p-value then of 0.0036. We'll compare this to alpha, and we could see this is less than or equal to alpha equal to 0.05, which implies we're going to reject the null hypothesis and basically support or accept the alternative hypothesis. All right, so interpret your conclusion in the context of the problem. And to do that, you might say something like the following. At the 0.05 significance level, there's enough evidence to support that at the time of the article, more than 40% of all US adults consider China as the leading economic power in the world. Okay, you can also use the calculator to do these calculations. So here I have the calculator opened in Excel. And so here we go. We know we have a sample size of 1,015 US adults. We know 448 of them agreed with the statement. And we know that the claim value of P was 0.40. Okay, so now that we have our thing, that automatically computes our P hat. But now let's answer the question. What parameter does the test involve? It does not involve a mean, but it does involve a P. And it was a right tail test. So then here we need to change this to greater than. And then make sure we put our significance level of 0.05. And then what sampling distribution it is. Well, it is normal, but there's other choices here. We want normal. And then what is the samples to test statistic? It's not this one here, but it's the second one down. That looks like this here. And that's Z equal to P hat minus P. Okay, so we get a test statistic of 2.69. That's what gets spits out here. It was the p-value it was a right tail test, so we got 0.0036 to 4 decimal places. And the conclusion is to reject the null and accept each one since the p-value is less than or equal to alpha. And in this case, this kind of shows our data is significant. All right, that's it for this video.